On May 9, 1963, a Thor Agena rocket lifted off from Vandenberg Air Force Base. Its payload wasn't a spy satellite. It wasn't a science probe. It was 480 million copper needles, each one 1.78 centimeters long, thinner than a human hair. Together, they weighed 20 kilograms. The plan: disperse them into a ring around Earth at 3,700 kilometers altitude. Create an artificial ionosphere, a giant radio mirror that couldn't be jammed, couldn't be destroyed, couldn't fail. The project had a name: Westford. And for a few months in 1963, it worked. The needles formed a diffuse belt. Radio signals bounced off it. The Pentagon could communicate across the Pacific even when the natural ionosphere was disturbed by solar storms or nuclear tests. Then the needles started to fall. By 1965, most had re-entered, burned up, gone. But not all of them. Today, more than 60 years later, thousands of those needles are still up there, circling Earth, invisible, indestructible, waiting. And they're not the only thing we left behind. This is the story of Project Westford. The time we built a Starlink prototype in 1963 and then pretended it never happened. Let's start with the problem, because the problem is always where the story begins. It's the late 1950s. The Cold War is hot. The U.S. military relies on high-frequency radio, bouncing signals off the natural ionosphere to talk to forces across the Pacific. But the ionosphere is moody. Solar flares disrupt it. Nuclear tests, and there were many, black it out for days. The military needs a backup, a mirror they control. Enter Walter E. Morrow, MIT Lincoln Laboratory. Brilliant, ruthless, practical. His idea: dipole needles. A half-wave dipole antenna resonates at a specific frequency. Make it exactly half the wavelength of your radio signal, and it reflects that frequency perfectly. Make 480 million of them. Cut them to 1.78 centimeters, half wavelength at 8 gigahertz. Scatter them in orbit. You get a persistent, global, man-made ionosphere. Immune to solar flares. Immune to nukes. Always there. It sounds insane. In 1958, it was cutting edge. The project was classified. Funded by ARPA. Managed by Lincoln Lab, launched by the Air Force. First attempt: October 21, 1961. Atlas Agena. The canister failed to disperse. The needles clumped into a useless blob. Failed. Second attempt, May 9, 1963. Thor Agena. This time, the canister spun. Centrifugal force flung the needles outward. They spread into a torus, a donut-shaped cloud, 3,700 kilometers up. Inclination 87 degrees. Nearly polar. Within days, the cloud was dense enough to reflect 8 gigahertz signals across the Pacific. Voice. Teletype. Data. The Pentagon had its mirror. It worked. But here's where the story takes a turn. The scientists knew the needles wouldn't stay forever. Solar radiation pressure. Atmospheric drag at 3,700 kilometers. Thin, but real. The needles would decay. They estimated most would re-enter within 5 years. A few might last decades. They were right about the first part. Wrong about the second. By 1967, the belt was gone. Radio reflections faded. The experiment was declared over. Classified files were archived. Everyone moved on. Vietnam. Apollo. The Cold War heated up. Westford was forgotten. But physics doesn't care about classified memos. The needles were copper. 1.78 centimeters long. 0.18 millimeters diameter. Dipole antennas. Perfectly passive. No batteries. No electronics. Nothing to fail. At 3,700 kilometers, atmospheric density is low. But over decades, it adds up. The needles with the lowest perigees fell first. The ones with higher apogees, the ones that got a slight boost from the ejection mechanism, they stayed. And copper doesn't rust in vacuum. It doesn't degrade. It just orbits. Fast forward to the 1990s. The Space Surveillance Network, the U.S. military's radar catalog of everything in orbit, starts seeing something weird. Tiny objects. Thousands of them. In a shell around 3,500 to 3,800 kilometers, polar inclination. No launch records match. No known satellite breakup explains them. Then someone digs through the archives, finds the Westford files, matches the orbital parameters. The needles are still there. Not all 480 million. Most burned up decades ago, but the ones in the highest, most stable orbits, they're still up there. Current estimates, thousands to tens of thousands. Still circling. Still reflecting 8 gigahertz signals if anyone bothers to listen. They are the oldest human-made objects in orbit that aren't a satellite. Older than Vanguard 1. Older than the first weather satellites. They are pure, simple, eternal dipole antennas. Waiting. Now, here's where the story gets uncomfortable. West Ford wasn't an accident. It was a deliberate dispersal of debris. The U.S. military chose to put 480 million pieces of metal into orbit. They knew they couldn't track them all. They knew they couldn't retrieve them. They knew most would stay up for decades. And they did it anyway. Why? Because the Cold War didn't allow for what if. The military needed a communication backup now. The long-term consequences were someone else's problem. Sound familiar? Fast forward to 2024. Starlink, OneWeb, Kuiper, Guam, megaconstellations, tens of thousands of active satellites, hundreds of thousands planned. We're doing West Ford again, but bigger. Active satellites with propulsion, radios, lasers, orbit plans. Better, right? Maybe. But the fundamental dynamic hasn't changed. We put things in orbit because we need them now. The long-term cost is an externality. Someone else's problem. Future generations' problem. West Ford was 480 million passive needles. Starlink Gen 2 is planned at 30,000 active satellites. Each one hundreds of times more massive. Each one a collision risk. Each one a potential debris generator if something goes wrong. Kessler Syndrome, the cascade of collisions creating more debris, creating more collisions, was a theory in 1978. Today, it's a risk assessment. And the needles? They're still up there. Part of the background noise. A tiny, invisible fraction of the total debris population. But they prove the concept. We can fill the sky with junk, and we will. Let me take you to the radar room. It's 2 a.m. at the 18th Space Control Squadron at Vandenberg. Screens glow with thousands of tracked objects. Red dots, yellow dots, green dots. One screen shows a faint cluster at 3,700 kilometers, polar. Thousands of tiny returns. The algorithm flags them as debris, origin unknown. The analyst knows. She's seen the briefing. She knows what they are. She types a note, West Ford dipoles. Still there. And the radar keeps sweeping. The needles keep orbiting. The sky keeps filling. Now the twist. You might think this is a story about space junk. It's not. It's a story about time horizons. West Ford was a solution designed for a 1960s problem. It created a 2020s problem. The people who launched it are dead. The institution that authorized it has been reorganized twice. The classification was lifted in the 1990s, but by then, nobody cared. The needles don't care. They don't know the Cold War ended. They don't know Starlink exists. They just orbit, obeying Newton, obeying drag, slowly, inexorably, falling. The last of them won't re-enter until the 22nd century. A decision made in 1961. Consequences lasting until 2100 plus. That's the hidden mechanism. Every launch is a mortgage on the future, and we keep signing without reading the terms. So what do? We can't retrieve the needles. They're too small, too numerous, too high. We can't clean them up. We can only wait. But we can stop writing new mortgages. Active debris removal, it exists. Clear Space 1, ESA, ADRIS-J, JAXA, commercial tugs. They're slow, expensive, one object at a time. Megaconstellation licensing. The FCC now requires 5-year to-orbit plans. Good, but enforcement is weak. Waivers exist. International law, the Outer Space Treaty, says avoid harmful contamination. But harmful is undefined. Contamination is unenforced. We're still building the ring, just with smarter satellites. And we're still pretending the bill will never come due. The needles don't blink. They don't transmit. They don't maneuver. They just are. A ring of copper around Earth. 480 million tiny mirrors, reflecting a war that ended before most of us were born. And every time a new rocket lifts off, Starlink, OneWeb, a spy satellite, a crewed mission, it punches through that ring. A few needles get knocked lower. They'll burn up sooner. A few get knocked higher. They'll stay longer. We're still writing the mortgage. Every launch, every satellite, every piece of debris. So the next time you see a shooting star, a streak of light in the night sky, remember, it might be a rock from the asteroid belt, Or it might be a 1.78 centimeters copper needle.